Algebra I 11.3c, cube roots. The number c, whatever it stands for, is the cube root of a if c to the third power is equal to a. See? We write this as c is equal to, we've got the a inside the radical symbol with the little 3 as the index. See that? That means c times c times c. So if we have 27 inside the radical symbol with the little index of 3, it's the cube root of 27. What number can be cubed to equal 27? We need to find a number that we can multiply to itself 3 times that would get to 27. 3 times 3 is 9, times 3 is 27. So the cube root of 27 is 3. The cube root of 216 is 6, because 6 times 6 times 6 equals 216. 6 to the third power, or 6 cubed, equals 216. And if we've got the cube root of negative 216, it would be a negative 6. Negative 6 times negative 6 is positive 36, times negative 6 gives us negative 216. We find and pull out perfect square roots to start looking for the cube roots. Now, what we've learned as rules for square roots also applies to cube roots, but we can find the cube root of a negative number. We couldn't do that with the square roots, could we? Square root of a negative number is not a real number. The cube root of a positive is positive, and the cube root of a negative is negative, because we're doing it 3 times. See? These two make the positive, and then the third one makes the negative. If we have the cube root of 125, it's 5, because 5 times 5 is 25, times 5 is 125. It's 5 to the third power. The cube root of 1,000 is 10. 10 times 10 is 100, times 10 is 1,000. It's 10 to the third power. We call that little number the index, or the order. It's up here. It's not some big number in front. Don't be fooled, okay? It's a little tiny number that's tucked inside the check mark. When the index of the radical is even, the radicand, the number that's inside of here, must be non-negative. It must be a positive or 0. And when we see something like the cube root of x to the 12th, we can do x to the 4th times x to the 4th times x to the 4th. So it's going to equal x to the 4th. Remember, the product rule of exponents as we add the exponents, so 4 plus 4 plus 4 is 12. See? Same thing with this one. Cube root of a to the 6th power would be a squared plus a squared plus, a squared times a squared times a squared, because when we're multiplying them, we add the exponents, so it's going to equal a squared. Now, there's positive roots and negative roots. And when you see it just like that, that's just a positive square root. See? It can also be written like a negative, with a negative sign in front of the radical. Cube roots are written with the little 3. Fourth roots are written with the little 4 as the index. Fifth roots are written with a little 5. And there's even nth roots when we don't know what n stands for, what value n has. We can have a negative cubed root. We can have a negative 4th or a negative 5th or a negative 6th, etc. When you see something like negative 4th root of 16, 2 times 2 times 2 times 2 is 16, isn't it? And this negative goes back there. It's a negative. See? If you see a negative on the outside of the radical symbol and a negative on the inside, nope, that doesn't exist. You can't do that, all right? But if there's a negative out here, then you can just put the negative back there when you've figured out what the 4th root of 16 is. 2 times 2 is 4, times 2 is 8, times 2 is 16. That's the 4th root of 16, see? Our next video, 11.4, we're going to talk about multiplying radical expressions. And of course, if you want a link to any of the previous videos in Chapter 11, they're all going to be in the description of this playlist. And I hope that'll help you, make it easy on you so you can just click on them. I'm going to continue on, and we're halfway through Chapter 11, and I'll see you next video. Multiply radical expressions. Bye.